Okay, we're going to do 4.2 quadratic equations. This is a review from Algebra 2. All of these things you should have seen before. 4 ways to solve quadratic equations. First is factoring. Now, factoring is nice, short and easy, but it doesn't work for every single problem, so it's limited in what it can do. Jumping down to number 4, graphing calculator is the same way. Graphing calculator is if we put the equation in and graphed it and looked for x-intercepts. That's nice if there are x-intercepts. When solving quadratics, you don't always get real solutions. You could also get imaginary solutions, which the graphing calculator cannot tell us. So the graphing calculator, again, is short and easy, but not that simple. But does not work for every single problem. 2 and 3, though, do work for every single problem, completing the square and quadratic formula. That's why you must know how to do one or both of these ways of solving. We're first going to start with factoring, just to review that quickly. Okay, solve x squared minus 6x minus 16 equals 0 by factoring. To do that, we set up 2 sets of parentheses. Now, the first term in each of these, okay, right here, and right here, are going to be factors of x squared. The second term is found by looking at the factors of the last number. So, well, the number in front of x squared is 1, and there's only one way you can break that up. 1 is 1 times 1, so we get x and x. 16, we could say 1 and 16, 2 and 8, 4 and 4. All right, so which of these do we use? Well, to check, we need to figure out what's going to give us this middle term, negative 6x. And to do that, we have to look at the outside and the inside. If we multiply the outside together, okay, and then we multiply the inside together and either add or subtract, that should give us that middle term of negative 6. Also, another thing that we have to keep track of is the signs. The second sign here is a negative. If that's negative, then the 2 signs that we use in our binomials will be opposite, either plus minus or minus plus. If that was a positive, then we would look at the first sign and write that one twice. In this case, if this was a plus 16, we would go to the negative 6 and write negative twice. But it's a minus, so we have plus minus. Also, if that second term also tells us if we're going to add or subtract the outside and the inside. Since it's a minus, then we are going to subtract. So, what 2 numbers do we subtract to get 6? 8 and 2. Now we need a negative 6, so I'm going to put a plus on the 2 and a negative with the 8. So the outside, if we multiply this out, we get negative 8x. The inside, we get positive 2x. And if we add those together, we get negative 6x. So that checks out. We factored this properly. Now we set each factor equal to 0 to finish the problem. Now, there's a couple different ways that we can check our solutions of negative 2 and 8. One is to use the graphing calculator. So let's hit number 4 right now. Solve by using the graphing calculator. Well, we're going to graph it. X squared minus 6x minus 16. And set it equal to 0. So y1 is left, y2 is the right. In this case, 0. Zoom, 6. All right, so we definitely have a parabola. We're missing the bottom part here. Oops. Missing the bottom part, okay? There's a minimum down there. If you wanted to see it, we could change the y min. And there it is. There's that minimum. Okay. What we're interested in are the x-intercepts. So right here and right here. And we can calculate those a couple different ways. Second trace, calculate. We can calculate the intersection. Intersection is very nice because you just have to get the cursor, or in this case the blinking x, near where you think the x-intercept is. Okay, and what this is doing is it's finding the intersection of our equation, x squared minus 6x minus 16, with the y-axis, which in this case is 0. So with y1 and y2. So we just hit enter 3 times. 1, 2, 3, and it'll find it. And it's saying x equals negative 2, which is one of our solutions. We can do that again over on the other side. Again, we get it as close as we can to where we think the x-intercept is. If you're using intersection, hit enter 3 times. You get 8. Again, this only works if you have 2 lines. If you only have y1 and not y2, you can't intersect things. So please put in both y1 and y2, calculate the intersection. You can check all of your solutions with that. So those are the 2 easy ways to solve quadratics. They're fast, they're short, but they don't work for every single problem. So they're limited in what they can do. Completing the square, though, works for every single problem, no matter what. So here it is. Solve 3n squared plus 7n plus 7 equals 0 by completing the square. Step 1. Step 1 when completing the square is that you must have a plane square term. Squared term currently has a 3 in front of it. We cannot have that. The 3 must go away. We will get rid of that by dividing all of the terms by 3. Okay, once we have the squared term to be a plane squared term, we are now going to move the number component over to the opposite side. And replace it with a quantity squared. So we're going to subtract the 7/3 over. If we put a quantity squared on the left side, we must balance it out with a quantity squared on the right side. And this is where the completing of the square happens. Okay, we needed to get rid of the number because that number did not give us a perfect square. We are going to make a perfect square. To do that, you must take half of the number that is in front of the n, or whatever variable you're using. In this case, it's n. So half of 7/3. Quick and easy way to do that, simply double the number that's on the bottom. So doubling 3 gives me 6, 7/6. So put 7/6 in the quantity. That has completed the square. Let me show you how. If we square this out, we get 49/36. And then on the right side, let's go and put this in. So negative 7/3 plus 7/6 squared. And we always want a fraction. So negative 35/36. All right, so the left side was a completed square. So we should be able to factor this. All right. Now this factors to the square root of 49 over the square root of 36. So we got 7/6, n plus 7/6, n plus 7/6. It's the exact same thing. Check it out. If you do the outside and the inside, 7/6 plus 7/6 is 14/6, which reduces to 7/3. So this is correct. We can write this as a quantity squared because we have it twice. Now, if you get good enough and you practice enough of these, essentially you could skip those two steps because the pattern of solving completing the square is exactly the same every time. Okay, if you write the variable n plus whatever the number is inside of the quantity squared. Okay, so it is a positive 7/6. Positive 7/6. Quantity squared. It's that way every time. So if you want to skip those two steps, you could. To finish solving, we're simply going to take the square root of both sides. Solve for n. Now we're going to deal with the radical. So we take the square root of the top and bottom. Square root of 36 is 6. Now, the negative we have to factor out. So that's an I. Square root of 35 is 7 times 5. That does not reduce. Okay, and to put it in proper form, since it is a complex number, and we talked about this before, it should be in the a plus bi form. We have two solutions here. Negative 7/6 plus the square root of 35 over 6i, and n equals negative 7/6 minus the square root of 35 over 6i. We have two imaginary roots. That means that factoring and the calculator are pretty much useless. I mean, we can look at it in the calculator. Let's go ahead and put the original problem into the calculator. X squared plus 7x plus 7. Okay, I still have that 0 in there from before. Zoom 6 to start, and there we can see it. This is a parabola. It's going up forever. It will never, ever, ever cross the x-axis. Okay, we'll never, ever, ever get the solution. There are no real solutions. There are two imaginary roots. Okay? No real ones. So in order to figure this out, we must use algebra. The calculator will not help us here. So that's completing the square. Quadratic formula is another option. The roots of a quadratic equation of the form ax squared plus bx plus c equals 0 are given by x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You must memorize this. Okay? And also remember, it must be of this form. If it's not equal to 0, you need to make it equal to 0 before you can use the quadratic formula. Way too many times I still have people that are solving it, but they're not moving into the right form. They might have a number on the right side of the equation, and they just use that as their c. It doesn't work. Okay? You have to make sure it's equal to 0 before you use this. So it's just plugging the numbers in and getting the answer. Solve negative 16t squared plus 80t plus 3.5 equal to 0 using the quadratic formula. This is of the correct form. So we can immediately write down that a is negative 16 B is 80, and C is 3.5. Once we have that, let's practice rewriting the formula. Easy way to memorize things is to write it down over and over and over. Every time you solve using quadratic formula, write down the formula. Okay, we have our A, B, C. We have our formula. Let's plug them in. Negative 80 plus or minus the square root of B squared, or 80 squared, minus 4 times A, which is negative 16, times C, which is 3.5. All over 2 times negative 16. Now we just need to reduce this. So we'll use the calculator here. We get the number underneath the square root. So 80 squared minus 4 times negative 16 times 3.5. So negative 80 plus or minus the square root of 6624 all over negative 32. Okay, we need to reduce this radical. In order to do that, I would suggest using what I call the cake method, and that's taking the number 6624 and just breaking it down by dividing. If we divide by 2, and again, you can always use your calculator to confirm all of these numbers. You can divide by 2, we get 3312. You can divide by 2 again, 1656. And again, we can divide by 2. 828. And divide by 2 again. 414. If these are ending in even numbers, you can always divide by 2. That's why I keep dividing by 2. Now, this is not ending in an even number, so it's not divisible by 2. Next thing I would do is I would add up the numbers inside. So we have 207. 7 plus 2 is 9. 9 is divisible by 3, so 207 should be divisible by 3. 69, which is 15, so that should be divisible by 3. 23. 23 divided by, that should be, it's 5. That's prime. That's not going to be divisible. So we're done. We've completely broken down the number, okay, into all of its factors. I call it cake because it kind of looks like a wedding cake. It's all stacked up. Put sides down the other side. And it's leaning a little bit, but I think it looks like a cake. So every time you have two numbers, those are factored out. So we got a 2, a 2, and a 3. So 2 of them come out as 1. 2, 3. So 2 times 2 times 3 is 12. What's left over? 2 and a 23. That's 46. All over negative 32. Okay. Now that we've reduced the radical's done. Okay, we're not going to look at that anymore. Now we're simply going to look at the numbers that are left. We have an 80, a 12, and a negative 32. The square root of 46 we do not touch anymore. So 80, 12, and 32. Can we reduce that? What will go into all of those? How about 4? So negative 20, 3. Again, the square root of 46 is untouched, and negative 8. So our solutions are x equals negative 20 plus 3 square roots of 46 over negative 8, or x equals negative 20 minus 3 square roots of 46 all over negative 8. Those are the exact solutions. Anytime you get a square root solution, you should also get a decimal solution. So, negative 20 plus 3 square roots of 46 divided by -8. And if we recall that, change it to a minus. 5.043. Now, why did we do that? Well, because we can always check our answers. Right? These are the exact. These are the approximate. Okay? If I go to y equals, I can graph this just like I graphed the other ones. I get 16x squared plus 80x plus 3.5. Start with a zoom 6. Okay, it's very steep. Okay, you see the parabola's going up, peaking, come back down. If we make the window higher, say 100, I don't know if that's going to be high enough. Okay, it's very close. Let's go 150, that should be good enough. I'm also going to change the y min to -50. We'll see why in a second here. All right, so we can see the peak, the max, if we need to figure that out. Okay, but we're interested in the x-intercepts. One close to 0, one close to 5. Again, since y2 is equal to 0, we can calculate the intersection, number 5, and enter 3 times, and it'll find it. So we got -0.4, there it is. .043. And we can calculate the intersection on the other side as well. 5.043. The other reason why, just a little side note here, I did change the y min to -50 so that when I was at the graph, I could see my solution when I calculated my answer. So I can actually see the x equals the intersection. If you don't change that, often the x-axis will be covered up and it's difficult to see where you're at. So that's why I moved that up. So that's quadratic formula. And that's it. That's all I have for you. This ends 4.2 notes.